This is a review of function transformations and modeling. This is AP Pre-Calculus Topics 1.12 through 1.14. If you appreciate this content, please give it a like. Selected values of the continuous function g of x are shown in the table above. Use the values in the table to answer the following. Number 1. Let h of x equal negative 2 times g at x minus 3 minus 5. Part A. Find h at 0. Plugging 0 in for x gives us this. So now we have negative 2 times g at negative 3 minus 5. But that's negative 2 times, and g at negative 3 is negative 4. But this is just 8 minus 5, which is equal to 3. So that's it for part A. Part B. Finding h at 3 means plugging 3 in for x right here, which gives us this. Next we have negative 2 times g at 0 minus 5. G at 0 is 3. So that brings us to negative 2 times 3 minus 5. This is negative 6 minus 5, which is equal to negative 11. So that's the answer to part B. Part C. If h at k is equal to 5, then find k. First of all, h at k means plugging k in for x. So that's negative 2 times g at k minus 3 minus 5. And all of this must equal 5. Let's get function g by itself. Adding 5 to both sides, we get negative 2 g at k minus 3 is equal to 10. Dividing both sides by negative 2, we get g at k minus 3 is equal to negative 5. Now you ask yourself, g at what is equal to negative 5? Well, g at 6 is equal to negative 5. That means that the k minus 3 that's inside of here must be 6. Adding 3 to both sides, we find that k is equal to 9. So that's it for part C. For number 2, n of x is equal to 2 plus g at x divided by 3. And I copied the chart down here so I wouldn't have to scroll up. Finding n at 3 means plugging 3 in for x right here. So that's going to be 2 plus g at 3 over 3. Alright, you saw it. 3 over 3 is 1. So I'm just going to do that. And then g at 1 is 6. So this is going to be 2 plus 6, which is 8. Part B. Finding n at negative 3 means plugging negative 3 in for x. Obviously, this is negative 1. G at negative 1 is 2. So we have 2 plus 2, which is 4. For number 3, h of x is equal to 6 times f at x plus 2 minus 3. For part A, we need to find f at 4, but function f is inside of function h. It is not given in a table. This is a table for function h. So we need to pick an x value that will cause f at 4 to show up inside of here. So if x was 2, that would give us f at 2 plus 2, which will be f at 4. So that's why we need to start out with h at 2. So that means h at 2 will be 6 times f at 2 plus 2, also known as f at 4, minus 3. H at 2 is negative 3. So all of this will equal negative 3. Let's solve this equation for f at 4. Adding 3 to both sides gives us 6 times f at 4 is equal to 0. Dividing both sides by 6 gives us f at 4 is equal to 0. And that's it for part A. For part B, we need to pick an x value that will cause f at 0 to show up. If x is negative 2, we will get f at 0. So let's let x equal negative 2. So that means we need to do h at negative 2, which is going to equal 6 times f at negative 2 plus 2 minus 3. H at negative 2 is 1. So we get 1 is equal to 6 times f at 0 minus 3. Let's solve for f at 0 by adding 3 to both sides. That gives us 4 is equal to 6 times f at 0. And then dividing by 6, that's 4 over 6, which is 2 over 3. So 2 over 3 is equal to f at 0. So that's it for part B. Number 4, let h of x equal negative 2 times g at x over 2. Part A, find g at 6. So we need to pick a value of x that will cause 6 to appear. Obviously that means x needs to be 12. So h at 12 will equal negative 2 times g at 12 over 2. H at 12 is 11. So we get 11 is equal to negative 2 times g at 6. We need to solve for g at 6 by dividing both sides by negative 2. So we get negative 11 over 2 is equal to g at 6. That's the answer to number 4. Number 5. Let s of x equal a times g at bx plus c, where a, b, and c are positive constants. The graph of s can be constructed by applying 3 transformations to the graph of g in this order: a horizontal dilation by a factor of 3, a vertical dilation by a factor of 4, and a vertical translation by a factor, well, by negative 5, not by a factor of. We need to build an expression for s of x. A horizontal dilation by a factor of 3 will be caused by a 1/3 x inside g of x. A vertical dilation by a factor of 4 will be caused by a multiple of 4 right in the front. A vertical translation by negative 5 units will be caused by a minus 5 right here on the end. So here's an expression for s of x. Now we need to find s at 3, which will be 4 times g at 1/3 times 3 minus 5. 1/3 times 3 is 1, so this is 4 times g at 1 minus 5. And g at 1 is 6. So we have 4 times 6 minus 5. That's 24 minus 5, which is 19. So that's the answer to part A. Part B, s at negative 9. So this will be 4 times g at 1/3 times negative 9 minus 5. 1/3 times negative 9 is negative 3. So we have 4 times g at negative 3 minus 5. G at negative 3 is negative 4. So that's 4 times negative 4 minus 5. That's negative 16 minus 5, which is negative 21. So that's the answer to part B. Part C, if s at k is equal to negative 9, find k. S at k means plugging in k for x. So let's begin by writing 4 times g at 1/3 k minus 5. And this should equal negative 9. We need to solve this for k somehow. Let's start by getting the g function by itself. Adding 5 to both sides, we get 4 times g at 1/3 k is equal to negative 4. Dividing both sides by 4, we get g at 1/3 k is equal to negative 1. This is where we ask ourselves g at what is equal to negative 1. G at 4 is equal to negative 1. That means this expression inside must be 4. So we now know that 1/3 k must equal 4. Multiplying both sides by 3 gives us k is equal to 12. If you had to watch the video to do number 5, please pause the video and try to do number 6 by yourself. I'm going to assume that you just did that. So we need to build an expression for h of x. So let's see, h of x is going to equal a horizontal dilation by a factor of 1/3 will happen if we have 3x on the inside of the function. Horizontal dilations always look the opposite of what they do. So 1/3 will be triggered by a 3x. A vertical dilation by a factor of 2 will happen if we have a 2 multiplying out in the front. And a vertical translation by negative 4 units will happen if we simply have a minus 4 on the end. So this is h of x. Now, for part A, we need to find j at 6. We need the expression j at 6 to show up right here. So we need to pick a value of x that will cause j at 6 to appear. Let's let x equal 2. So h at 2 will equal 2 times j at 3 times 2 minus 4. So h at 2 is negative 3. Negative 3 is equal to 2 times j at 6 minus 4. We need to solve for j at 6. Let's add 4 to both sides. We get 1 is equal to 2 times j at 6. Dividing both sides by 2, we get 1/2 is equal to j at 6. And that is the answer to number 6, part A. Part B, in order to find j at negative 3, we need to pick a value of x that will cause j at negative 3 to show up. Let's let x equal negative 1. So let's start with h at negative 1 is equal to 2 times j at 3 times negative 1. Let's just go ahead and put negative 3 minus 4. H at negative 1 is 0. So we get 0 is equal to 2 times j at negative 3 minus 4. Adding 4 to both sides, we get 4 is equal to 2 times j at negative 3. And dividing both sides by 2, we get 2 is equal to j at negative 3. So that's the answer to part B. Number 7. The graph of f of x is shown in the figure to the left and consists of 3 line segments. Let g of x equal 1 minus f at 2x. Sketch the graph of g of x on the same axes as f of x. My strategy is to perform the transformations that I see on the 4 key points of function f. Here are those 4 key points. The transformations that affect the x values will appear on the inside of the function. This 2 in front of the x will cause a horizontal dilation by a factor of 1/2. The horizontal dilations are always the opposite of what they appear. So 2 becomes 1/2. If this were 1/2, it would really be by a factor of 2. So therefore the transformation will be 1/2 of these x values. That's going to give me -2, 1, 2, and 3. The transformations that affect the y values are outside of the function. There are actually 2 of them. I see this negative sign and the 1. But I can really just do 1 minus y, like this. So let's see. 1 minus -4 is really 1 plus 4, which is 5. 1 minus 2 would be -1. 1 minus 0 is 1. And 1 minus 2 is -1 again. Now all I have to do is plot these 4 points, the purple ones, and connect the dots. Here are my first 2 points. My next point is at 2, 1, which will connect up like this. And my last point is at 3, -1. So 3, -1 will be just like this. Label the purple graph as g of x. Let's look back and see the 3 transformations that happened. First of all, having this 1 in the front would be the same as having a +1 on the end. So, as I mentioned before, having a 2x on the inside is a horizontal dilation by a factor of 1/2. So this purple graph should be 1/2 as wide as the original graph. And we can see that. This negative sign is a reflection over the x-axis. So the purple graph should be upside down compared to the original graph, and you can see that it has been flipped. The translation by +1 is a little bit harder to see because the graph is upside down. So it looks like maybe it has been shifted down 1, but that's just because it's upside down. It really was shifted up 1 and then reflected. Number 8. The graph of f of x is shown in the figure to the left and has a domain of -3 to +3 and a range of -5 to 3. Let g of x equal f at x plus 2 minus 1. Sketch the graph of g of x on the same axes as f of x. Here are the 5 key points of function f. Now let's do the transformations that affect the x values, which will be on the inside. The x plus 2 is actually a horizontal translation by -2. So we will do x minus 2. Subtracting 2 from all the x values gives us this. The transformations that affect the y values will occur outside of the function. The -1 simply means the y values will be subtracted by 1. Subtracting 1 from all the y values gives us these new y values. Now we can just plot these new transformed points on the graph. Here are the 5 key points of g of x. Notice that the graph of g of x is simply shifted left 2 and down 1 compared to the original f of x. Number 9. The domain of h is from -4 to 7, and the range is from negative 6 to 0. Find the domain and range of g, where g of x is equal to 2 times h at x minus 3. Domain values are x values, so the x values originally go from negative 4 to 7. Range values are y values, which originally go from negative 6 to 0. The transformations that affect the x values are on the inside of the function, and they are always the opposite of what they appear. So the x minus 3 is a horizontal translation by positive 3. So we will do x plus 3 to get the new x values, the new domain values. So let's see, negative 4 plus 3 is negative 1, and 7 plus 3 is 10. The transformations that affect the y values occur outside of the function, and they look just like they act. So multiplying by 2 in the front means 2 times all the y values. That will give us a negative 12 and still 0. So the new domain will be from negative 1 to 10, and the new range will be from negative 12 to 0. If you use interval notation, your domain and range will look like this. Number 10. The domain of a function j is from negative 6 to 10, and the range is from negative 9 to 0. Find the domain and range of k, where k of x is 1/2 j at 3 times x minus 2. Domain values are x values, which originally go from negative 6 to 10. Range values are y values, which originally go from negative 9 to 0. The transformations that affect the x values are inside the function, and they are the opposite of the way they appear. So multiplying by 3 on the inside is actually a horizontal dilation by a factor of 1/3. So we're going to have a 1/3 x here. And then the x minus 2 is actually a horizontal translation by positive 2. So plus 2. 1/3 times negative 6 is negative 2. Plus 2 is 0. 1/3 times 10 is the same thing as 10 over 3. I need to add 2 now, but I'd like to have like denominators. So instead of 2, I'm going to put 6 over 3. So this is 16 over 3. So here's the new domain. The transformations that affect the y values are outside the function. This 1/2 means 1/2 times all the y values. Half of negative 9 is just negative 9/2. Half of 0 is 0. So the new range will be from negative 9/2 to 0. Number 11. The domain of function m is from negative 4 to 7, and the range of m is from negative 6 to 0. Find the domain and range of n, where n of x is equal to 4 minus 3 times m at 2 times x minus 1. Domain values are x values, so that's from negative 4 to 7, and range values are y values, originally from negative 6 to 0. Transformations that affect the x values will show up on the inside of the function, and they will be the opposite of what they appear. So multiplying by 2 is actually a horizontal dilation by a factor of 1/2. So 1/2 x. X minus 1 means a horizontal translation by positive 1. So plus 1. Half of negative 4 is negative 2. Plus 1 is negative 1. Half of 7 is 7 over 2. Plus 1 is the same as plus 2 over 2, which is 9 over 2. The transformations that affect the y values appear on the outside of the function. So this 4 minus 3m becomes 4 minus 3y. 4 minus 3 times negative 6 is the same as 4 plus 18, which is 22. And 4 minus 3 times 0 is 4 minus 0, which is just 4. So here's the domain and range of function n. Number 12. A small business sells computers. Its per item profit based on number of produced is given in the table below. Use technology to find the quadratic curve of best fit for the data, a quadratic regression model. Then use that model to predict the business's per item cost when producing 4 computers. Round to the nearest dollar. Here's a trick that I should mention more often. It's good to reset your calculator and start from sort of a clean slate. You can do that by hitting second plus 7, 1, 2. Here's what I mean. Hit second plus 7, 1, 2. That just resets everything and gives you a fresh calculator. So do that right now so your calculator will look just like mine. Now hit Stat and Enter. And we want to enter the input values as L1 and the output values as L2. Now we will do the quadratic regression model. So hit the Stat button, switch to the Calc menu, and choose option 5 for quadratic regression. Before you calculate, go down to where it says Store Regression Equation, and store this as y1. Hit Alpha, Trace, and Enter for y1. Now just hit Enter a couple more times, and here is your regression model. I strongly recommend recording 4 decimal places unrounded. Even though the College Board will accept 3 decimal places, rounded or truncated, experience tells us that students make mistakes with the rounding. So I think it's better just to use 4 decimal places and no rounding. So here is the quadratic regression model. I'm noticing that the data is profit. So I think right here where they said per item cost, they meant per item profit. The per item profit for producing 4 computers will be predicted by y at 4. We can do this on the calculator because we let the entire regression model be stored as y1. We can pull up y1 by doing Alpha, Trace, Enter. And we can evaluate y1 at 4 by putting a little 4 next to it in parentheses. This avoids any rounding error. Make sure you do not use the rounded numbers that we wrote down on the previous screen. So this is the answer. To the nearest dollar, that is $37. Unless they specifically tell you to round, leave your answer with 4 decimal places, no rounding. The College Board will accept 3. Number 13. Billy is shooting off a model rocket with a deployable parachute. Throughout its initial flight, Billy records the height of the rocket at different times following the launch. Billy then records his data in the table below. Use technology to find the quadratic curve of best fit, the quadratic regression model, for the table data. Then use that model to predict the height of the rocket after 3.5 seconds, when the parachute deploys. Let us again enter the input values in L1 and the output values in L2 on the calculator. We hit Stat and Enter, and we remember that we already have this data typed in. Just go up to the title and hit Clear, Enter, and that wipes it out. Clear, Enter. To calculate the quadratic regression model, let's hit Stat, switch to the Calc menu, and choose option 5. Before hitting Enter, let's go down and tell the calculator to store the regression equation as y1. Alpha, trace, enter. Hit enter a couple of more times, and kabam! There is your regression model. I highly recommend that you record 4 decimal places, no rounding, even though the College Board will accept 3 decimal places. Here's the quadratic model. To estimate the height at 3.5 seconds, we need to evaluate y at 3.5. Let's use the calculator. So we can pull up the y by doing alpha trace enter, since we stored the entire model as y1. And to evaluate at 3.5 seconds, we simply put 3.5 in parentheses like this. So there's the answer, 75.1555. And don't forget the units, which are meters. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.